That. Shall we start?
Yes, sir.
Yes, sir.
Yes, sir.
Everyone had your lunch or not? Or you have to take after class?
No, sir, we have taken.
Right,
After class, sir.
after class. So we are going to use the PPTs here of PPTs of the person who have shared in the internet. He was Ghaffari. So we have to thank him first because he has provided this material to us. He is very ready-made. What I thought means I can also prepare the same thing again and again, but rather than reinventing the wheel, we have to use the wheel for the progress. So in this online, I want to thank him for providing the PPTs. So we are going to use that. So a simple uh, this figure shows us a simple line for production or assembly. Assembly is a section where we are going to assemble the goods and products. So here, first input will be in the workstation. One workstation is a place where some starting amount of work or some piece of work, some machine will be there, some piece of work will be done, and it will be moved to the next workstation. That is second workstation, third workstation, and fourth workstation. Here we have four workstations, and you will get the output. So a simple line. It is called line for production. So here in this we can see the activity classification, value adding. So each and every stage the value addition will be going on. Any process that changes the nature, shape and characteristics of the product in the line with customer requirement, that is called machining and assembly. So directly raw material we cannot give to a customer, so we have to do some processing, some finishing should be done. That is nothing but it's a value addition, non-value adding, but unavoidable with current technology or methods. Any work carried out that doesn't increase the product value, that is the inspection, part movement, tool changing, maintenance. Here there is no value addition. Tool changing, we are going to use one spanner for this and one screwdriver, and we are going to use so many tools in order to do something, but that is not in value addition. Whatever you are going to work on the workpiece is called the value addition. These are non-value editing activities or inspection. I'm going to see that whether it is going to happen or not. There is no value addition over there. Just we are going to monitor the what's going on, and we are going to see the part movement. Part movement means the particular piece what we have re-engineered will move to the one station to another station. There is no value addition, but at the workstation the value addition will be done. Example, if you are going to take agriculture product, if you are going to say industrial product, their process differs, but value addition at each level it will be going on. If you are going to see the supply chain management, it starts from backward integration to the forward integration, that is from raw material will be subjected to go down. From the go down they are going to sent to the production unit. From the production unit it moves to the again finished goods, then they will be wrapped in the packaging and they will be bundled up and they will be kept in the godown. From their distribution it tax, this is the whole value chain will be there. So here non value adding is unavoidable because inspection we have to do, tool changing, maintenance, that will be done. Waste, we should not waste, but some waste will be the all other meaningless non-essential activities that do not add value to the product can eliminate immediately. That is looking for tools, waiting time, idle time. I said in the starting that how machines are idle, people are idle, that we need to avoid it. So this is the activity classification in a production unit. So wastes are caused from transportation while moving. You would have seen example, classical example that wastages in transportation. Every time I tell in the class regarding this rice, fair price shop, that is in the ration dealer, we are going to get the rice from MLS point, from the mandal level supply unit we are going to get, and to that mandal level supply unit from the district level CWC godowns, This paddy will be moved to the rice mills, and then you are going to get rice. Rice will be stored in the FCI godowns. That FCI godowns is they will be sending to the mandal level uh, points, that is MLS point. From that, a lorry load will go to the village, and in village we have 3 or 4 dealer shops. There they are going to dump. So in transportation from CWC go down to the mandal level stock point, from mandal level stock point to the village, and village to that fair price plus dealer, spillover will be there. That's why when we go to the dealer shop, we have 2000 people under one dealer shop. If they go and ask for rice, he says, I got only 2 3 bags, and that for 100 people or 200 people it has been come. Actual, if you are going to see the sheet, compulsory for 2000 people, some 10 kgs of rice, 20,000 kgs would have been come. But while coming spillover, no one is going to concentrate on much. So that will be reduced. So wastages in the transportation, inventory, that is while storing also, wastage will be there. If you are going to keep idle like that, only stock will be deteriorated and they will be spoiled. Some wastage will be there. Example, we have two level of methods in storage. That is, while distribution we are going to use LIFO method, FIFO method. LIFO method means last in first out, and first in first out. First in first out is in case of perishable items, whichever comes first that should be delivered out. And last in first out is industrial product like benches we have, tables we have, iron rods we have. Whenever they come, we can shift it, because the longer time if you hold also nothing will happen. But perishable items, compulsory, we have to see that when it has come and it should be first moved. So that is the thing in case of inventory. Motion means movement. While taking the momentum, while moving the products from the go down to the workstations and to somewhere, if you are moving, spillover will be there. You would have seen our Banya, the shop owner, he is going to go for retailing of our products. For a 1 kg of sugar, it is 50 rupees suppose. If you are asked for 50 grams, otherwise 100 grams, 50 rupees means 5 rupees should be there. He asked for 10 rupees. Why? Because for that 100 grams he has to go inside and he has to pick up, and while coming compulsory some spillover will be there. While momentum of the products, compulsory spillover, that wastage he is going to take from you. So if you are asking for 100 grams, exactly that rate will not be there. If you are asking for 250 grams, the exactly 1 by 4th will not be there. And if you are asking for half kg and kg only, the rate will be there, 50 rupees, 25 rupees he will give for half kg. But if you go for 250 grams, again it compulsory it should be around 1250, he says 15 rupees. So that is the wasting. There he is going to make it up. That is a retailer risk. Waiting. Wastage, if you are going to wait, example, if you are going to take the paddy and wait for longer time, the moisture will be gone and it becomes very light. So in waiting also some wastages also will be there. Overproduction. Wastage. If someone is asking for 10 kgs of rice, if you have prepared 100 kgs of rice, then only 10 kgs of rice will be distributed and 90 kgs will be kept idle in your workshop or in your godown. Then what happens? The sudden demand should come, then we have to sell. Until then it will be non-moving stocks. That is, stock will not move, they will be get deteriorated. That is wastage will be there. Over processing, over producting, defects. With the defects, you would have seen, if you go to some bookseller, if you want to pick up a phone or anything, if any scratch is there, we are not going to take. What he will do with that? That is a wastage. So these are the waste that we need to avoid. So this is unbalanced line, simple example. So here you can see at the corner overproduction, which causes other 6 wastes, 5 minutes, then here 25 minutes, again 15 minutes, again 10 minutes. So here from one workpiece to one workpiece you are going to. So here 5 minutes and 25 minutes constant overburden here, and this operator must wait for operator 2, means he has to complete this 25 minutes, he has to wait. First 5 minutes is the work done over here, over production. He got 6 waste. He has sent over here. And in the second unit here, 25 minutes he is going to take, means 30 minutes this person has to wait. This operator must wait for operator 2 to complete this. So here, if you are going to see this person, 5 minutes plus 25, that is 30, and 45 minutes he has to waste, and after 45 minutes, only 10 minutes of work he is going to come. This operator must wait for the operator 3. So here, what happens from one workstation to another workstation to another workstation while moving, here we should not make much time, otherwise this waiting will be wastage of time here. So some processing we have to take here, overproduction he has made it, and you can see this, he is taking much time over here and he needs 15 minutes here. So total time you are going to see. So this is very unbalanced, a simple example. So, what is line balancing? Is the process of assigning tasks to the workstation in such a way that the workstation have approximately equal time requirements. So, the process may be there. Means from one operator 5 minutes. If you are going to take 5 minutes, again we are going to go for second. That is, he will take 10 minutes, 15 minutes. This third operator has to wait. But more than that time, we should not make it. So we have to see the line balancing, means these workstations according to the timers they have to work, so that our completion time, like project work example, you can see any project if you are going to take, we have 3 months of project that we need to complete it. So we are going to assign the activities, and if the project is delayed, then it will further go from 1 month. If you are going to delay, again 1 month it is going to get extended, like that. Projects, 10 projects in a group, so 10 projects means 10 delays, it is going to become 1 year. You would have seen your examinations has been postponed, they have been delayed. So that delayed has become delayed and more delayed and more delayed it is going to become. So in production we cannot do that. So line balancing is the process of assigning tasks to the workstations in such a way that workstations have approximate equal time requirements. So we have to see that the work is done in within the time. Why we have to do this? Because customers are waiting over there. They have demanded for the product. We have to finish up this, and we have to make that particular product available to them in the market. Otherwise, we are going to lose the market. We are going to lose the demand also. For that reason, time management should be there. So line balancing objectives we are going to see now. That is the main objective is to equalize the workload among the operators, to identify the bottleneck operation. Bottleneck means any problems that we need to identify and we have to solve that. To establish speed of production line. Here, this is very important that speedy work. Even example, if you are going to Simcoe Bakery or Modern Bakery or Cake Bank or somewhere, you are going to give an order to some recipe, some cake you are going to get. How long you will wait? You will wait for 10 minutes, 15 minutes. Whole day, if you are going to make you to wait, you will be wait over there. No. So some time will be there for the processing, some time will be there for the delivery. That time compulsory he is going to say, we don't have now available that particular cake. We need 1 hour of time. You can give order, take the slip, and you can come back after 1 hour. I'm going to deliver this. So even after 1 hour, if you come and keep standing for another hour, you are going to ask the money to pay back and you are going to move on. So the same thing, it happens that inside that kitchen or the bakers or confectioner is the establishment of speed lines of product line, production line, speed up we have to do. That determine the number of workstations, to determine the labor cost of production and pack out, to establish the percentage workload of each operator, to assess the plant layout, how the movement of the work should go on, that also layout you have to see, to To reduce the production cost, also we have to see these are the line balancing. You would have seen any retailer that is either Reliance or Everyday or Ali Smart or Ashmi Brothers or Raghavendra or supermarket. We have more everywhere you go. Some line will be there, that is the layout will be there, to plant layout. They will be moved from where we have to go and where will be having the exit. That clear cut will be there. So like that only in our production unit, that is the manufacturing process, there also we have going to plan for the plant layout. So these are the objectives, what the line balancing we have to do. Methods, how we are going to do this. There are many ways and methods for balancing the lines. The common thing of all the methods is using the operating machine in the most effective way, the same time producing flexibility in the production. So we are into uh, we are into line balancing. Here we need to see the operator of the machine and that is the machine, that is effective way they are going to do that. So the effective way, the same time productive flexibility in the production, that we need to see. So the method is we have to see the operator and the machine should be sync, so that it is the very effective. So that was unbalanced. I will make it back. This is promotes one piece flow 15 minutes. Here one piece is there. Next value added, some star, some light. Again they have done this. This is 15 minutes. They have done and avoids overburden. Slowly it is moving, minimizing the 7 waste. That is 6 waste we had. So here they have made it. So reduce here, reducing variation here. So redistribution of work we can do. So here it is idle. We can distribute this work over here. So this is a balanced way that you can take the screenshot. How the balanced will be there. So this is bottleneck workstation taking the longest time, and required cycle time total available by the required output, and the current cycle time we have same as a bottleneck time. Current cycle time means the workstation is taking the longest time. The required cycle time is total time available by required output. This some calculations. Flow time means time to complete all. Here you can see the stations, one station, two station, three station, 2 minutes, 5 minutes, 3 minutes. Flow time is 2 plus 5 plus 3 is 10 minutes. Current cycle time is 5 minutes. Why? Because current means we are at the second stage. So where are done? This is your port CPM. We have methods. I think in OR you are going to do this. So while doing the OR, this port CPM methods, you once you ask for me so that we can sync that. In that we are going to see one activity, A, B, F, G, H is one type of method doing completing that work. A, D, F, G, H also another type. A, E, G, F is another type. In simple example is, if you want to take memo, either you can go directly to the admin and controller of exams, that exam branch directly we can take, or you have to go to our college, and from college we can take, they are going to get from there. So there are some ways. If you want to reach our college, we have so many ways like that. Here this is a network showing the order of tasks, restrictions in their performance, total work content, sum of task, times for all production. Here timing will be different. If you are going to reach our college from clock tower, we have one way and we have another way and another way. The timing and traffic also differs. So that we are going to take and we are going to calculate that in over. You are going to see here also we may do some problems after soon after this completion of the line balancing prerequisites. Determine minimum rational work elements, and this is smallest feasible division of work that we have to do. Determine cycle time, calculate theoretical minimum number of workstation, draw precedence diagram means which this network diagram we have to drive. A simple algorithm, identify tasks, determine the available tasks, choose a task that fits your task with largest time or more successors, So this is regarding that network diagram. Which one you want to take the way? Continue steps 1 to 3 until your task fits. Means which route is the best route? Either you need that in less time or longer time. So here A, B, E, C, D are the task. These are the timings. Preceders means before A there is no activity. Preceder to A we have B. Means after A it is B, then C and D, then E and F, then G and H. The timing also been written. This is how we are going to draw. Here we have C and D. Here we have F and H. Why? Because here they have written preceder is A and preceder of F is B and C. F means after this you are going to get. So this is how we are going to make a diagram. And current cycle time is bottleneck 18 seconds and current number of stations are 6. So total product per day, total time available per day by cycle time, we are going to take 8 into 3600 into 80 by 360. Here 3600 means the time available per day they have taken. So it's an just calculation. Normally, we don't have these calculations, but it is of engineering subject. So we have here we got 90 seconds and work content 380 seconds. Number of stations 4.22 means exactly there are 5 workstations in this. So here, this you are going to completely you will be knowing in the war, but I am going to show the diagram. Mostly we don't have this. A, B, F, H means 80 seconds, 30 seconds, and 50. It becomes one way, and 40 seconds, 50 seconds, 50 is another way. 20 seconds, this is shortest route. If I want to go into 90, I will be moving. So this is how we are going to draw these preceding diagrams, and the tasks we are going to see the task time per CPM that we are going to learn in further classes. It doesn't come here, but how it is balanced that I'm showing here. These are the examples. And these are the parallel workstations we have, elimination of waste. So this is the advanced subject I'm showing you, but we have only what is line balancing, what are the objectives of line balancing only. So value added, this is the mostly waste under this is waste. We have to eliminate the waste while doing that. So here what you need to concentrate is what is mean by line balancing, what are the objectives of line balancing, how the line balancing will be there. That is a small topic in our unit 2. So this we call it as a day. This is what I have thought of presenting to you for today. In the next class, we are going to see the facility layout and factory layouts that we are going to see in the next. These are small topics only, but as it is subject, they have from the engineering.